faced in the exam with something that looks like this, and you can see through all of these that they've got something in common. They're all being subtracted. That's because these are the difference of two squares. When we subtract, we're finding the difference. Really important skill is to know your square numbers. And well, let's begin with the theory. In the green, on the right hand side there, in the green writing, we have two double brackets. And these double brackets have a special property when expanded, when multiplied together. You'll see we've got an x and a y in both, but one's positive and one is negative. That's the important part about this. When expanded, you get x squared plus xy, subtract xy, subtract y squared, which when simplified with those two middle terms, just cancelling each other out, we get x squared minus y squared, which is a unique situation to be with a quadratic. You usually expect three terms. Now, recognizing the difference between these two square numbers and going backwards is what we're doing today. So noticing we have this and then going back into brackets is technically called factorising. And so it's a very special case. Why is it important? It's because in the exam, they will often put this in, and it's not necessarily that there's another, there's not another way of doing it, but this will certainly save you time if you can recognize it. So let's start with the first one in the top left. What do we look for? Well, we're looking here for the difference, as in a subtraction, and some indication that there might be squares. We'll see a bit later, perhaps, you might see in other questions that they're not necessarily obviously squares, but you can still square root them to get to it. So once you recognize that you have something squared, take away something squared, we open up a couple of brackets. We think, well, what goes in there? Well, it's something to do with this term and this term that go here and here. Okay, and in fact, it's the square root of those terms. So you're wondering what goes in each of them. Well, certainly one of them's positive and one of them's negative. And what goes here is the square root of the first term. And what goes here is the square root of the second term. So let's probably just do for this first one, the working out at the side. So if we square root the 9x squared, we end up with 3x. So that's our first term. And if we then square root the 4y squared, that's going to leave us with 2y. And those are our two elements. The 3x is going to be at the front of the bracket, and the 2y is going to be at the second half of the bracket. Very, very important tip here, I would say, is that put them in the brackets in the order that you see them in the question. So if the 9x squared comes first, then that should be the first term in the bracket. I know you can have 2y switched with 3x, but I've seen people get confused doing it any other way. Let's have a look at the second question then. So it's very similar. In fact, before we do, have a quick think if you want to pause the video and just have a go. Maybe you just get it straight away. I have given you pretty much the fundamentals. See if you're right. Don't be afraid to make a mistake. So if you've just resumed the video, here we go. Opening up our brackets, we've decided that it is the difference of two squares because we've got some squarey things subtracted. We're going to give it a go trying to put them in. So the root of 25x squared you should have found as 5x. So that could go straight away. You know, one's positive, one's negative. The square root of 49z squared is 7z. And that goes in the second half of each, and you've done it. Obviously, you can go on and solve it from there, but it's often used to cancel things down. So look out for it when doing algebraic fractions and cancelling. This third one is here because actually people don't recognize it as a square number just because of this number 1. It's true, you don't always think of it as a square number like 4 or 9 or even x squared. So just be aware to to recognize it. It's used a lot, actually. It's more simple than the other ones. There's no coefficient. So in the case where there's no coefficient, you're just square rooting a simpler term. You're square rooting x squared, which is x. And interestingly, you're going to be square rooting the 1, which is 1. So plus and minus. That's it. You can double check this by expanding the brackets, but you factorized it. Over here again, yeah, you see it looks a bit different, doesn't it? But we're just going to use the same method. You could argue that it might not be fully factorized, but we'll just do one round of it to see if you get it. Hopefully when you had a go yourself, you had a good go at this one, and hopefully get it right. We can do it separately, but I'll just do the one term separately because it's the odd one. You probably noticed that x to the power 4 is the odd one. Now the square root of 4 is obvious. You can do these separately because the rules of surds, you could tackle it like this. And further rules of indices say that this is technically x to the power 4 to the power of a half. So if you're wondering how to square root x to the 4, well, you have 2 from the square root of 4, and when you have brackets, you multiply them together. So we're going to have x squared. So the square root of 4x to the 4 is 2x squared. So we're going to have 2x squared at the front of each bracket there. One's positive, one is minus, and the square root of 16y squared, we're probably used to seeing that as 4y. Notice how that's become a simple thing to do compared to 4x to the 4. And there's your factorized form there as such. Now, I suppose you could look at the second bracket, but I'm not going to go into that now. That's just the way to do the difference of two squares at that level. And we'll look at the last one. This is where we have 3 elements on each of the sides, but it's kind of squarey, and it doesn't really matter due to the fact that, for example, if I had 144 written as 12 squared, like this, I can take that squared out, so it's 12xy all squared. So if you're thinking about it as a square number, okay, well 49 is 7 squared, but 12xy squared is 144x squared y squared. It's still got a square element to it. So if we square root, open our double brackets here, we've got the square root of 144, and then the square root of x and y goes in our first element place. One's positive, one's subtract, and in the second half we can just work through one at a time, and it's actually rather simple when you get to it. You've got 5, m and n, 5, m and n. You could probably make your own question up, get it as ridiculous as possible, and it's actually a good way of learning, you know, trying to make a question that is as difficult as you could possibly think, and seeing what that limit is.